Hey guys, and welcome back. This video will review how to solve for variables. Solving for a variable is an essential skill that will be used throughout all of algebra and beyond. I like to simplify the idea of solving for a variable into getting it alone on one side of the equation. Look at this equation, x plus y equals z. I can solve for x by getting the equation to look like this. Here I just solved for y, and here I solved for z. I just wanted to show that all I'm trying to do is get the variable I want to solve for alone on one side. But that begs the question, how do we get the variable alone? I would like to propose do the opposite way of thinking. Let me explain what I mean. In any equation, we will have numbers being added, subtracted, divided, and so on. If we do the opposite operation, we can get these numbers away from our variable and get it alone. I'll quickly list the operations and their opposites. This would be a good list to write down if you are just learning this. The operation of addition finds its opposite in subtraction. And the opposite of subtraction is addition. The opposite of multiplication is division. And as expected, the opposite of division is multiplication. Now, when a variable is being raised to a power by an exponent, the opposite of that would be to root by that same power. And vice versa, if a variable is being rooted by a certain power, the opposite would be to raise to that same power with an exponent. And last but not least, when dealing with fractions, the opposite of a fraction would be its reciprocal. Now let me give you an example of how to get x alone by doing the opposite. Here we have 2x plus 5 equals 15. Is the x alone? No. I'm going to point out the operations being done around the variable and work to do their opposite, starting with addition and subtraction. I see a 5 being added. Here I'll ask, what is the opposite of addition? It's subtraction. So we will subtract 5 from both sides. Remember that whatever we do to one side of the equation, we must also do it to the other side. Subtracting 5 from both sides gives us 2x equals 10. Now with 2x, we have a 2 being multiplied with our variable. Again, I'll ask, what is the opposite of multiplication? Hopefully you said division. Divide by 2 on both sides and we get our final answer of x equals 5. Now let's try this one. The square root of x divided by 2 minus 3 equals 2. I see a 3 is being subtracted. We have to do the opposite to get x alone. So I will add 3 to both sides, which leaves us with the square root of x divided by 2 equals 5. Is our x alone yet? Nope. We still have a few operations to get through. Let's start with the square root. Do you remember what the opposite of square rooting is? The opposite of square rooting is squaring. So we will square both sides, giving us x divided by 2 equals 25. Note that we squared both sides because square roots are another way of saying root by the second power. And the opposite of rooting by a power is to raise by that same power. Our x is still not alone though. The variable is being divided by 2. Now what is the opposite of division? That's right, multiplication. Now multiply both sides by 2, which brings the 2 over to the other side, finally getting x alone and giving us our final answer of x equals 50. With our third example, 3/4 y plus 2 equals 8, we have 2 being added. We subtract 2 from both sides and are left with 3/4 y equals 6. The fraction in front of the variable can be brought over to the other side by multiplying both sides by its reciprocal. Now, what is the reciprocal of 3/4? Hopefully you figured out that it was 4/3. We multiply both sides by 4/3, giving us our final answer of y equals 8. And in our final example, x to the 5th equals 32. X is being raised to the 5th power. In order to get x alone, we do the opposite of raising to the 5th power and root by the 5th power. Our final answer being x equals 2. And that's it. Thanks for watching. Hopefully that shed some light on how you can approach solving for variables. Good luck.